Example. Find the equation of the line passing through point with coordinates -3, 5 and perpendicular to the line through the points with coordinates 2, 5 and -3, 6. Solution. Slope of line through the points two, 5 and -3, 6 is 6 minus 5 divided by -3 minus 2 is equal to 1 divided by -5. Slope of line perpendicular to the line through points 2, 5 minus 3, 6 is equal to 5. Therefore, equation of line through point with coordinates -3, 5 is y minus 5 is equal to 5 into x plus 3. This implies y minus 5 is equal to 5x plus 10 implies 5x minus y plus 15 is equal to 0. A line perpendicular to the line segment joining the points with coordinates 1, 0 and 2, 3 divides it in the ratio 1:n. Find the equation of the line. Solution. Let L be the line which divides line segment joining the points A with coordinates 1, 0 and B with coordinates 2, 3 in the ratio 1:n at P. Let line L is perpendicular to AB. Let us draw one rough figure. Therefore, coordinates of point P are one into two n into one divided by 1 plus n, comma 1 into 3 plus n into 0 divided by 1 plus n, that is n plus 2 divided by 1 plus n, comma 3 divided by 1 plus n. Slope of line AB is equal to 3 minus 0 divided by 2 minus 1 is equal to 3. Since line L is perpendicular to AB, therefore slope of line L is equal to minus 1 by 3. Therefore, a required equation of line is y minus 3 divided by 1 plus n is equal to minus 1 by 3 into x minus n plus 2 divided by 1 plus n. This implies 1 plus n into y minus 3 divided by 1 plus n is equal to minus 1 by 3 into 1 plus n into x minus n plus 2 divided by 1 plus n. 1 plus n, we can cancel both sides. This implies 3 into 1 plus n into y minus 9 is equal to minus 1 plus n into x plus n plus 2. This implies 1 plus n into x plus 3 into 1 plus n into y minus 9 minus 2 minus n is equal to 0. This implies 1 plus n into x plus 3 into 1 plus n into y minus n plus 11 is equal to 0. Find the equation of a line that cuts off equal intercepts on the coordinate axis and passes through the point with coordinates 2, 3. Solution. Let x by a plus y by a is equal to 1 be the required equation of line. That is 1 by a into x plus y is equal to 1. This implies x plus y is equal to a. Say number 1. Since 1 passes through the point coordinate 2, 3, therefore 1 implies 2 plus 3 is equal to a. This implies a is equal to 5. Substituting a is equal to 5 in 1, we get x plus y is equal to a, that is 5. This implies x plus y minus 5 is equal to 0 is the required equation of a line. Show that 9 raised to the power n plus 1 minus 8n minus 9 is divisible by 64 whenever n is a positive integer. Solution. Let us take 9 raised to the power n plus 1 minus 8n minus 9 is equal to 9 raised to the power n plus 1 can be written as 1 plus 8 whole raised to the power n plus 1 minus 8n minus 9 is equal to 1 plus 8 whole raised to the power n plus 1 can be written as using binomial theorem 1 plus n plus 1 c1 into 8 plus n plus 1 c2 into 8 square plus n plus 1 c3 into 8 cube plus dash 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 plus n plus 1 c n plus 1 into 8 raised to the power n plus 1 minus 8 n minus 9 we can keep as it is. This is equal to 1 plus n plus 1 c1, that is n plus 1 into 8 plus n plus 1 c2 8 square plus n plus 1 c3 8 cube plus dash 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 plus n plus 1 c n plus 1 into 8 raised to the power n plus 1 minus 8n minus 9 we can keep as it is. This is equal to 1 plus 8n plus 8 plus, let me take 8 square common from these terms. When you take 8 square common, then what is left? N plus 1 C2 plus n plus 1 C3 into 8 plus dash 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 plus n plus 1 C n plus 1 into 8 raised to the power. So we would like to take 2 out. So now at present we have got n 8 raised to the power n plus 1. We wanted to take 2 out. So to balance that minus 2, let us write. So it is nothing but as a 8 raised to the power n minus 1 into 8 square. So when you take 8 square, so what is left? 8 raised to the power n minus 1 minus 8n minus 9 you can keep as it is. Now plus 8n and minus 8n will get cancels. 1 plus 8 9 minus 9 we can cancel. This is equal to 8 square 64 into bracket n plus 1 c2 plus n plus 1 c3 into 8 plus dash 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 plus n plus 1 c n plus 1 to 8 raised to the power n minus 1. Now we have got 64 into something. So which is divisible by 64? Prove that summation of 3 raised to the power r into ncr r is equal to 0 to n is equal to 4 raised to the power n. Solution. LHS is equal to summation of 3 raised to the power r into NCR r is equal to 0 to n is equal to S 3 raised to the power 0 into NC0 plus 3 into NC1 plus 3 square into NC2 plus dash 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 plus 3 raised to the power n into NCn. This is equal to 1 plus 3 into NC1 plus 3 square into NC2 plus dash 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 plus 3 raised to the power n into NCn. Is it not looking like the expansion of 1 plus x whole raised to the power n? Here what is x? 3 is x. This is equal to 1 plus x according to the formula, that is 3 whole raised to the power n is equal to 4 raised to the power n, that is RHS.